Right, so this is going to be the first video on the P39709 camera syllabus, and we're going to be starting off with algebra. And within algebra, the first topic that we're going to look at is modulus. So a modulus is usually denoted by a double straight bracket with a function or an equation within the bracket. So what this does is that whatever number you have inside, say 7 modulus, right? What you're going to do is get its absolute value, and whatever the result this bracket produces, it will always be positive. So the modulus of 7 will be positive, and the modulus of -7 is also positive. So we're going to take a look at a few examples, and just to help you understand how we could solve questions regarding modulus. Say you have modulus of x is equal to 5. What are the possible values of x? And it's quite simple. The possible values for x will be 5. So as you put these two values back into the function, you're just going to get 5. What if we had x minus 2 equal 3? What you're going to do now is split this into two different equations. One is going to be the original one, x minus 2 is equal to 3, and the other one is just x minus 2 equal -3. So what we get now is x equals 5 and x equals 1. So these are your two solutions for this question. Now say we had something like, how are we going to solve this? You can't. There are no solutions for a modulus of something to be equal to a negative number. It's just not possible. So there are no solutions. And so now we're going to look at a more different example. Say we have modulus of x equals a modulus of 2x minus 1. Well, what are you going to do now? You cannot really take positive and negative. So how are we going to work with this? What you're going to do now is square both sides, right? And I'll tell you the reason for this later. So you're going to get 3x minus 1. I'm just doing this fast. 3x minus 1 and x minus 1. So your two solutions are x equal 1 over 3 and x equal 1. So the reason why I squared both of these is that whenever you square a number, it will always be positive. Say you have 7 squared, well, that's just 49. And if you had -7 squared, then that is also going to be 49. There is no negatives. Likewise, we're going to use the same principle as we did over here in this particular example. So that's that. So now what if inequalities are involved with modulus? Before we go through that, I want to show you some basic principles that you must know. Say you have 3 greater than 2, right? And say I multiply both sides with -1 times -1, you will be getting -3 and -2. What will be the inequality over here? Well, clearly it's just -2 is greater than -3 because the value of -2 will be greater than the value of -3, which just means that whenever you encounter this sort of problem, you're going to switch the signs. Same goes for reciprocal. Say you had 1 over 3 and 1 over 2. Which is greater? Well, it's clearly 2 again. So whenever you try to find the reciprocal, you must reverse the inequality sign. Say you had some like modulus of x is less than a. And a here is just some number that is greater than 0. So whenever you look at this statement, it just means that a is always a positive, right? So how are we going to go about this? Well, as we learned earlier, that x could really just be a or negative a. And we could just simply say that, well, x is just less than a and greater than negative a. But what if you had a question? So what if you had a question that was something like modulus of x is greater than a? Well, we know that x could either be a or negative a, but this time it's greater than a. So you cannot just say that x is all of a sudden less than a. It's not possible. So what are you going to do for that? If you remember from P1, you would just pretend that this is some actual graph, and these are its intersection points at A and negative A. So the region that you're going to accept is the one over here and the one over there. So what that means is that x will be greater than A and x is less than negative A. That is how you're going to solve this question. And say we had some like modulus of x minus b is less than A. What are you going to do next? Well, quite simply, you just treat this as a separate equation. X minus b is equal to A and x minus b is equal to negative A. You're going to get x is equal to A plus b and x is equal to b minus A, which now you're just going to get x is greater than A, is less than A plus b and greater than b minus A. That's it. Now, what if we had 2 modulus of x plus 1 greater than x minus 1? Some of you might be wondering, what could we do about 2 being outside the modulus bracket? It's nothing to be worried about. All you just got to do is square both sides, and you don't have to worry about why 2 is outside the modulus brackets. And you could just continue with this. You're going to get 0, and the values you're going to get are x is equal to negative 1 over 3 and negative 3. Now, as you can see, it's greater than here. So what are you going to do next is just decide that x is going to be greater than negative 1 over 3 and less than negative 3. I'll just show you a graph here. Well, it's negative 1 over 3. So they just want you to recognize this region, and that's pretty much it. Now, this is one of the more odd examples which I've rarely seen being tested in past papers, and it goes something like this: modulus of x minus 1 less than modulus of x minus 2. So what are we going to do here is, instead of just squaring both sides, we're going to treat this as 2 separate equations of y. And now what you're going to do is find the intersection points for both of these equations. So I'm just going to label this as 1 and this as 2. So for 1, if your y was 0, your modulus of x will be equal to 1. And since this could be either 1 or negative 1, your x values are just negative 1 and 1. So what if x was 0? If your x was 0, then your y is negative 1. For the second equation, if your y was 0, your x is going to be 2. And if your x is 0, then your y is just modulus of negative 2, which is just 2. Now we're just going to sketch a graph. It doesn't have to be perfect. We're just going to sketch it. And I'm going to assume where 1 and negative 1 would land here. So when y was 0, the intersection points were at x1 and x negative 1. So somewhere here and there. And when x was 0, your y was negative 1. So around here, I won't label that. So your first equation would be making this sort of diagram on the graph. And your second equation, when y is 0, x is 2, so somewhere here. And when your x was 0, your y was 2, so somewhere there. So this is your equation number 2. This is your equation number 1. Likewise, this is also equation number 2 and equation number 1. So as we can see from our statement that is given here, x minus 2 is greater than the modulus of x minus 1. And when does that happen? It happens after this point, after this intersection right here. So now we want to know is that what is that intersection, right? Before we begin, I want you to realize that this specific graph right now here, the specific line, is actually the negative of equation number 2 because it avoids the negative part. It was supposed to go down in the negative y region, but it's now in the positive y region. So what this basically becomes is just negative of x minus 2 of the second equation. And the first one remains as it is. So you're just going to have y is equal to x minus 1 because it doesn't, no, because in this case, your y is still positive and it's going as it was intended to go. So now you're just going to equate these two. I'll just clean this up a bit. 2 minus x is equal to x minus 1. You're going to get 3 is equal to 2x. So your x value is now 3 over 2. So as you could see from the diagram itself, as x decreases, that is the only region where your second equation will always be greater than your first. Your values of x, your set of values of x will be x less than 3 over 2. And that's pretty much it.